Not sure if we have, there we go. Maya. So when I create an enemy, and I do all these different animations for the enemy in the game, we needed all these different things to happen, right? We wanted the pumpkins to bounce. We wanted the pumpkins to bite, attack the player. We wanted the pumpkins to get hit, idle, do cool like little things when they idle. You can do two different things. One, you can put all those animations on one giant timeline within Maya or 3D Studio Max, and then in Unity, actually go through and sequence out all the different animations.
Tell it frame 1 to 40. Is this animation?
Exactly. You can. Exactly. I think that just takes too long.
Yeah.
I also like to. For me, I just like to keep things organized and have the separate files when I need them. There's bonuses and drawbacks to both ways of doing it. But for me, I like to just create a file and then create the different animation files as separate projects, basically. So if I need to edit a particular animation, I can just open the file, go in, edit it, save it out, done. I don't have to go in and redo all these different animations and stuff.
So if you were to do something like, I don't know, a tombstone.
A tombstone?
If you were going to do something like a tombstone in a 3D tool, what would be your process to start it out? What kind of shapes would you start with?
So for a tombstone, we can kind of look at what we did in the game, right? Do we have the game here, or do you have it?
Game is on this one. I could actually load it up on here real quick.
But yeah, it doesn't. Unfortunately, it doesn't look like Maya, so I can't really show you real time what I do modeling wise. But for a tombstone, I'd use basic shapes. I'm using cubes, definitely using the cube tool. I'm adding edge loops on it, and I'm just kind of extruding it and just making it and defining the shape that I want. If that makes sense, use your basic shapes as a starting point. There's a really, really good.
Here's a preview. We're gonna wait. We're gonna wait to show this, but this is your first glimpse
view of the project. You'll be able to download and play.
I'm not gonna run it now. You guys will have to wait for the 3D session to see that happen. But this is it here. So there's a tombstone. So you would, in the case of, let's take, I guess we could do the center one here.
Yeah.
Talk us through what you would do to create this process.
For that, I'm basically just using 3 shapes that are all kind of stuck together, right? I've got a hexagonal shape for my bottom platform.
This guy there,
right?
yeah.
It's just very, very simple. There's nothing going on that except for just a simple hexagon shape, right? Hexagon polygon shape. And then from there, on top of that, it's just a cube. Right on top of that, right? And then I've just distorted the cube a little bit to kind of give it a little bit of a flare, right? This kind of
I see along this kind of beveled edge.
Yeah, this kind of it's all it is. Very, very simple shapes. And then on top of that, I'm also using a cube for the cross part, and even a little platform lip on the top of that. They're all cubes, right? So that cross on the top, I just started with a cube in the middle, extruded the top, extruded the bottom, extruded the sides to get a really simple cross out of cubes, and then just extruded more to get like little beveled edges and different things, and then you just unwrap it. Yeah.
So you'd kind of take, so this is in Unity, which I did mention earlier is not really a 3D modeling tool, but you might take, let's go up.
Yep.
And then you would create another cube kind of.
Yeah, or I just create edge loops on that cube, and then extrude from the different shapes I create just to make the shape you need.
Little kind of square right here, and then you would pull that square off to the side.
Yep. And then you can just run with that, and I think the texturing goes a long way. Right, so don't think too much on, I've got to have all this crazy detail in the model. Like, yes, if the model is great, that means you don't have to work as hard on the texturing. But if the model is simple, right, and let's say you're doing a mobile game and you really need to be conscious of like your verts and your tries, and you really need to keep those low, what you can do is just really concentrate more on the texturing that you're going to put on those. So for that, I mean, you're looking at, I think it was like 300 tries total for that whole cross piece, but with the texturing, you can get a lot of leverage and you can get a lot of leeway out of taking this simple model, but adding all these really cool details and taking your time texturing it.
And by tries, you're talking about all these little kind of subdivisions on here.
Yeah, so
a little bit in the 3D course, but that's the triangles that make this up here.
Yeah, tries are just the triangles that make up a model, right? So when you ever hear that term tries, they're talking about the triangles that make up a model. There's 2 tries in every square, in every face, basically. So, that's basically all you're doing is you want to be conscious of your try count. For me, the mobile games I'm doing, I always like to use, this is just my reference, but if I'm looking at the amount of tries on mobile devices, I want to target a large mobile device, right? I want to do all kinds of different devices of every speed and whatever, at least like current gen models, right? I always want to target around 30,000 tries, I think, for my baseline of the amount of tries I want to see on the screen at any time. Anything over that, you're definitely going to get the newer devices will run that fine, but I think lower devices, which is your huge audience pool, you want to keep that as like your guideline. I always say 30,000 tries is like the limit. And then from there, you just want to be conscious on the characters themselves, right? Keep the try counts low. I always like to keep the try counts on my characters. If I have a lot of characters in the game, let's say it's like a hack and slash game and you're running around and all kinds of stuff, I would say I'd keep the try count on each character around 2,000, not go crazy on that. That's always worked for me, and that's just me. Right?
It all depends how many of those characters are in the scene.
Yeah,
too.
You could go higher. There's a lot of games out there with these really high characters, but there's maybe only 2 characters on the screen. So they can get away with all kinds of tries and all kinds of detail out of just 2 characters. But if you're doing like a huge epic like RPG style game or a hack and slash, and there's tons of characters jumping in the screen, you want to be very cognizant of the modeling of those characters and the tries that they account, because that's all memory, especially on mobile. It's going to fill up that memory really, really quickly. So just some little tips, you want to be cognizant of when you're building your mobile game. But yeah, I mean, that's pretty much my process when I'm doing things.
That's pretty cool. I noticed that some folks in the industry, you see that they use a lot of different tricks. Like, let me see if I've got one here.
Sure.
I don't think I have. We do have a palm tree here. So I can go ahead and place a ton of palm trees on this scene. And these look like they're all 3D models, which I just placed 10,000 of them on my scene here. That's the awesome button there, mass place trees. I love that. So if I was to drop a little character on here and start running around, you would think that it would be incredibly inefficient on here. But one of the tricks used in the industry is called billboarding, which Unity will do behind the scenes. So rather than showing you these 3D models, you can actually go in and specify some of the options here. And it will, in turn, basically create a 2D image that no matter where you rotate, kind of rotates with you. It looks like you're viewing a 3D model, but it's really just an optimized 2D image. And then as you get closer to an object, it'll show you the full 3D model, so you get that full kind of high-res detail. So all sorts of little tricks like that to optimize your scene.
Yeah, and there's another, like level of detail is another, and I think we're going to be talking about that when we get into the optimization module. But basically, you want to think about your models too. You can do high-res models if it's only going to be like one thing you're seeing on and we're just talking mobile here, right? Yeah. If you're doing PC, go nuts, right? Or Xbox or other things. Go crazy. But, on mobile devices, you really want to be cognizant of the elements you're putting and the elements you have on the screen at the same time, and doing level of detail, which means, you could do a high-res model, like the highest you can, but then maybe use a tool like, there's a tool that I use all the time called Topo Gun, where you can bring in a really high-res model and then retrace it at a really low resolution and low try count, but bake in all that detail from that high-res model. So it's almost like you're faking what you see, but you're also optimizing. And then you can do different levels of that depending on if you were doing, far up and there's characters in the distance, you could have a really low try count because you're not seeing all that detail. But then as it gets closer, it's actually swapping out different models and you're getting, you're eventually getting that high-res model. So
are you saying we might see some of the topo optimizations in our optimizations module?
Oh, absolutely. Absolutely.
Little hint of some things to come. Yeah. And that's module 6. That's our first module tomorrow.
Yeah, that's tomorrow. So yeah, we're gonna do some really cool stuff with that.
Amazing, absolutely amazing.
But meanwhile, I will get the Triceratops with the cyborg barbarian Triceratops alien thing. Yeah, I'm gonna get that finished. We're gonna throw it up probably tonight or soon that everybody can download.
In the next couple days, definitely we'll have content.
In the next couple days. And then I would love to throw that in a Unity project, just really simple to show you how we take that, create a sprite sheet, take all those elements, and then you can animate them and stuff.
I see. So even more cool things to come after this session today.
Really, really cool.
Well, thank you for joining us. Just a reminder, we're going to be taking a meal break. We'll return in about an hour, and then we're going to be covering 3D games. So we'll see you then.
Cool.
Hello, welcome back to our day of Unity learning session 2, developing 2D and 3D games with Unity on Windows. I'm joined now by another good friend of mine, David Crook, as we talk about this next section, one of my favorite parts. We're going to be talking about 3D. I did my intro before. I'm Adam Tuliper. I've got some added info on my slide at the bottom there. If you want to follow me out on Twitter, I'm always adding tons of cool stuff on there, Unity tips, training. And I want to mention that I have a 4-part session on Unity development coming out in MSTN Magazine. Actually, the second one on 2D just ran. 3D's coming out soon. And then we have the 4th one on building for Windows coming out next month. So that's enough about me. You are new to this, so welcome for your first session here. Excited to have you. Tell us about yourself.
This is my first MVA session ever. I'm David Crook. I'm a technical evangelist for Microsoft based out of Raleigh, North Carolina. Focus on gaming, cloud, development operations. I'm an ALM ranger and did a lot of development operations consulting at various Fortune 100 companies before being a evangelist with the Microsoft Consulting Services. You can reach me at the indiedevspot.com or also on Twitter at davidcrook1988.
Very cool. Welcome to Module 4, 3D game development. I'm excited. Are you excited?
I'm really excited. 3D game development is one of my personal favorites.
It's where the scenes come alive, right? What we're going to be talking about today in this module is 3D and Unity, of course. This is the module on 3D. Physics, vectors in Unity, reading input, creating zombie pumpkin slayer. So we'll kind of take some basic samples, piece them together, and you can understand how the actual final game was created there. It's still actually a work in progress. We are going to upload these assets to GitHub, and we'll have the assets available through GitHub, and we'll post those links out to our websites the next couple days. So you can see how everything was done. 3D in Unity. 3D.
It's awesome.
3D is simply X, Y, and Z. 3 coordinates. Unity actually has the left-handed coordinate system. So if you hold up your left hand, you can see we've got Y, X, or I should say X, Y, and Z is depth. In other words, into the screen, back out of the screen, that's Z. Very easy. If you remember high school math, you typically worked in 2 dimensions with a little graphs there. You had X and Y. And now with games and 3D stuff and really fast engines, we now have the Z that we don't worry about. I don't want to say worry about, that we have to our advantage now.
I kind of like to think of 3D more like 2D top-down, just with a little extra component coming up.
Another way too. Some of my favorite games like the Command & Conquer series, like Red Alert and, oh yeah, good times.
Love it.
Let's start talking first about physics in Unity. The 2 main components dealing with physics in Unity, rigid bodies and colliders. You don't have physics in Unity without those 2 components. And as we talked in the first session of the day, they are just simply components added to the game objects. Rigid body and collider. A rigid body is what gives your object mass. Without it, your object doesn't have mass. Gravity must have a rigid body. Your object will not fall if you don't have a rigid body component on there. So mass and gravity. You don't have to have a collider on it, which brings us to next, what is a collider? If you want your object to recognize collisions with something else, you have one cube going to another cube, there has to be a collider. So without a collider, your objects will just fall through each other. They will understand gravity, but they're just going to pass right through each other because Unity doesn't know how to calculate that. So 2 main things required, rigid bodies and colliders.
So what if I want to have a game with 2D and 3D components? Can I have the 3D colliders on my 2D or vice versa?
The 2.5D game?
Something along those lines, I suppose. Yeah, you know, sometimes I see those games where you've got the 2D platformers and the 3D models, or 3D models and 2D.
You can mix up colliders. There are specially built colliders in Unity optimized for specific purposes, though. So if I'm doing a 2D sprite in Unity, I want to use the 2D colliders. I think you can actually shoehorn the 3D ones on top of it and vice versa. But typically, if you're on 2D, you use the 2D versions of colliders, and if you're doing 3D, you use the 3D versions of colliders. And we'll look at what those components look like inside of Unity. So let's get to a demo here with some physics and go over to Unity. For this one, I will create a new scene. And this is going to be similar to what we saw in the first session here. But we're going to add a couple more details onto this. I just created a terrain that has a built-in collider. It's something that we can work with. In fact, if we want to make it look a little bit better, I can just add a texture that's already in this project. And I believe that I saw.
So this terrain tool, it comes built in to Unity, doesn't it?
The terrain tool is built into Unity. Last year, for the Microsoft Virtual Academy session, I did a whole section on using the terrain tools here to basically sculpt out your environment where you can just raise, do everything that you want on here.
Oh, cool. We can even add little stars. This is great.
Stars, which is a good mountain shape on here. But let's use this little world to kind of talk about some basic concepts. If my mouse will actually click and let me move over here. There we go. All right, let's take a couple cubes on here. First, let's zoom in a little bit more. All right, so let's take some cubes. And got 2 cubes here. Unity has dropped them right there, which that will work. As it stands now, if I play this game, my camera's probably looking somewhere else. In fact, I can see my camera's looking over here. That's okay, we're gonna switch back to this view. I'm playing my game, I'm gonna switch back to my scene. My game's running. Notice, I have a floating cube right now. Crazy, huh?
Yeah. Who would have thought you could have a floating cube in a world?
So Unity, this is simply a mesh with a texture on it, just floating in the sky, or shader on, I should say. 2 of them, actually. If we want physics to happen in this scene, what are the 2 things I said are required?
I think it was colliders and rigid bodies. Yeah.
So, let's go ahead. Let's move this over a little bit. Oops.
So what happens if I leave one of those guys off?
We'll show you. We being me in this case.
Yeah, I don't have anything up on my box.
So in this one here, I'm going to do a rigid body. And in this one here, we're going to add a collider. And to your question earlier, what about the different types of colliders? If we look at under physics and physics 2D, under physics, when we add a component, we have all the various 3D colliders. These are the ones that originally existed inside of Unity. And you generally use these based on whatever objects you're using. If I'm using a cube, I want a box collider. If I'm using some sort of humanoid or zombie, I want a capsule collider. So you try to choose one that matches. There are other ones like mesh collider, which will wrap the entire shape of your mesh. Very, very exact for physics, very, very expensive for computation time.
So I can use a couple of sphere colliders maybe if I got something that's double sphered.
Yes, and let's say you have a big
Dinosaur.
monster boss, dinosaur.
Yeah, dinosaurs
For monster
are great.
boss in a game, you can take different colliders down the legs and arms, and you can use multiple colliders to kind of flesh out the collision zones on that character. So on this one here, let's do a box collider, and this one we have a rigid body on the other one. So I'm going to click play and come back to my scene, and you notice what happened here. This guy,
It looks like it fell.
it fell.
And
Actually,
it looks
I
like
double-
it's rotating and
Actually-
hitting stuff.
I made a minor, let me double check something here because I think I made a minor boo-boo. I added a double collider here. The cubes by default actually have a collider on them already. I added 2 on there, not a huge deal, but that's why it was actually bouncing as it went down. If I remove that, so this is my rigid body, I'm going to remove that collider. Let's just get rid of it. Remove
Yeah,
the component.
completely. I love enabling and disabling the parts, though. It's fantastic.
And
Holy
there we go.
cow, it went through the floor.
Right through there.
I'm going to file a bug against you.
That's a common beginner mistake too, because either your objects don't have a collider, or let's add a collider back onto this. Add a box collider onto it, but I'm partially through my terrain. If you're already touching in the kind of the collision matrix,
Oh,
like let's do. Hold on, this is going to be problematic here because of my.
the collision system's a bit faster than your mouse,
It
is
is
it?
faster than me here. Let's try this guy here. See, it's acting funny now. It's popping up. Anyway, so one of the common things that you'll find, you place like a character controller, which we'll talk about shortly, objects on here, and they pass right through. That's typically because the collision zone is sitting just a little bit beneath the surface here. This is probably happening because of my raised terrain here. So I just want you to understand the basic components here. Rigid body gives your object mass, and you can actually assign a greater mass here to your object. This helps when one object is hitting another object. Who's going to win? Who's got the greater mass? That's what that affects.
Elephant versus the balloon.
That's right. Use gravity is checked off by default here. And you have other kind of more advanced options, like to be able to tell Unity, hey, don't rotate my object when it falls. I want to keep that rotation. And that comes in handy quite a few times. We'll look at that when we look at the game further. So what I did here was just a rigid body and a collider. Now let's take this a little bit further here and talk about vectors.
All right.
Like I said to Matt on the last session, Vector from Despicable Me. Did you see that movie?
I saw one of the Despicable Me's, but I was more enticed with the Minions.
Minions, love those guys. Vectors, they're just values. They sound confusing, and in math, they could be confusing. In Unity, they can actually take the place of a bunch of different things. They can be used to represent a rotation. They can be used to represent a direction. But in a nutshell, a vector is nothing more than a point, just two values. It's called x and y, but actually two values that by themselves have no meaning whatsoever. If you create a new vector, it's nothing more than essentially 2 points stored in an object. There's nothing special about it. A vector 3D object, which exists in Unity, just contains 3 values, x, y, and z. And again, they're just numbers. The fact that it's called x, y, z means absolutely nothing. They could have called it q, h, and a. It's just they try to map it to what you're using as your coordinate system in Unity. Vectors can represent different things, directions, values, forces. They can represent a rotational value. They're just values. And they can be relative too, which is something very important to understand in Unity. There's forward space, which if you were to hold up your left hand and we had x and y and z was depth. When you open your scene, you have these world coordinates. They're global. Forward is essentially z everywhere. Take a cube. Forward could be however the object is rotating. And you have the option of choosing one or the other in Unity. You can say, hey, in my world, I want to go z. Or I want to go z wherever my object is facing, which is actually forward. And so we'll look at a little brief example of that. Related to vectors, though, typically in Unity, you'll see in moving objects. And there's a bunch of different ways to move objects. In my MSDN series this month, I had, I think, 7 or 8 different methods listed of moving an object inside of Unity. And there's questions like, well, which one do I use? And the answer is it kind of depends. Typically, you add a rigid body to an object, and you move that rigid body by setting its velocity. So the first code example here shows we're setting rigid body velocity to, what did I say vector was? Just hold some values, right?
Yep.
So here we're saying 7 in the x, 0 in the y, and 0 in the z. In other words, move at 7 meters per second in x. Now, in the next one here, we're saying, same thing. We're setting the velocity on an object, but this one looks a little bit different. Sounds a little bit more complicated. The top one goes in the world coordinates. So the top one where it says vector 7, 0, 0, that is in my global world space, how that object's moving. In the example at the bottom, we're setting the velocity to transform direction. And that basically makes it local. So wherever that object is rotated, it's going to move forward in that direction. So one way of dealing with world, one way with dealing with local. And they both come into play in different cases.
Yeah, that's a pretty cool trick. I hadn't actually been using that. I'd been doing all of my stuff off of trying to translate it myself. So cute, cool little tip even for me.
So let's look at some essentials in Unity here. The way I want to kind of structure this, since we're going to look at a more advanced but still kind of basic game that we pieced together, the zombie pumpkin slayers. What we're going to do is talk about the basic components required for that. So input, movement, vectors, and collision. So let's go ahead and look at that demo. And I have another scene set up here called Cube Me. We don't need to save this one. So what is in this scene? I have a terrain, which I created in the last one, which is simply create a 3D object terrain. Gives us just some base to work on. I have, it looks like it's kind of a little bit textured here. This is just a rock texture. This is actually a completely flat surface. Even though it might look like it's not flat, it's completely flat. I have a few awesome cubes. And what I've done with these cubes is they have a box collider, which is there by default. I've added a rigid body to each of these cubes. And in the first session, I mentioned tag. It was simply a way to assign a text string to an object here. I tagged them as enemy cube. And we'll see why we do that in a second here. And then I have a cube with controller. So this is the special guy right here. This cube has its own component on there, a script. Let's look at what that script does. We have 2 code methods we're going to use here. We have update. Let's increase this font size just a little bit.
There we go.
So we have update. Now in Unity, when you want to read input, there's an input system in Unity. So if you want to read however you're moving horizontally or vertically, you call input.getAccess with this name. And what does that name map to? So if it's using a string here, horizontal, well, if we look over in Unity under our project settings, input. And there's a bunch of preset definitions here. Horizontal, the name horizontal means we're looking at the left and right arrow, or the A and the D key. Think of the common keyboard gaming keys. A and D move you left and right.
So why do I want to go through this instead of using the get key, input.getKey code?
I like using an axis, because axis you can map around. It's easy to, for me, conceptually represent horizontal and vertical. And then I have a whole input manager. I can easily swap them out and change them, or if I want to assign to a joystick.
So if I want to configure my own keys, it makes it a little easier?
Yep, absolutely. You can just set them right in here. You've got your own custom key definitions. So I'm just going to read horizontal here. And this is going to be a value between -1 and +1. And when you hold the keys down, Unity will actually scale that object, those values. And it kind of ramps it up pretty quickly. You can control how quick it ramps that value up. Let's just see what those values look like here. Let's run this. And I'm going to view my output here. Right now it's 0. I'm not moving anything. Let me find that cube. Oh, you know what I did? I turned off my camera. Turn that guy back on. All right, so I've got this cube right there. Input is currently 0. Now notice, as I press the D key or the right arrow, either one, I can see that cube kind of pressing over a little bit. And these input values, they scale up and scale back down again. Unity is actually collapsing these debug messages here. There we go, 0. So that's how we read our input. Now we can take that and we can map that to something. So we've got some value between -1 and 1. We can say, you know what? We want to move in our z direction by some value. In other words, whatever we're reading from our input. So we press the keys, we get this horizontal value. It's a pretty small value, so we're just going to multiply it by some sort of speed. In this case, I use 10. It's an arbitrary number. You kind of find what works for your game. And that becomes our movement vector. Again, it's just a value. It's 0, 0, and yet 0 for x, 0 for y, and in z, we have some value. And we're going to set our rigid body's velocity to move in that direction. So that takes care of moving over. Next, because we have a collider on this object, we can actually hook this method here, which is behind the scenes. Unity uses reflection to see if you have these methods defined in your class. And it calls onCollisionEnter and passes you this collision object, which is based off of whatever you collided with. So I'm doing a little debug log, this.name collided with whatever I've just collided with. Now, I said I was using a tag. And why am I using a tag? Because you can collide with tons of things in your game. Your cube can drop and collide with your terrain. It could collide with another cube. It could collide with all sorts of things. I only want to do something when I hit an enemy cube.
This kind of goes back to an earlier session when we were talking about prefabs, because the name, if we went off that, is possibly a clone, right? So if they're all tagged the same.
Yes. So in other words, I could say if collision.gameObject.name, but that name can change. To David's point, if I'm using other prefabs, we looked at prefabs in the first session, and I create one dynamically, which we use the instantiate call to do that with. If I create one dynamically, its name can change. It could have a parenthesis clone after its name. So we look for things by tag. And so I've tagged those cubes as enemy cube. If it's an enemy cube that my main cube collides with, I'm going to just destroy that enemy cube. Now, we're not destroying our collision object. Collision is a component. We have to pop up one level and destroy the root game object. This is something you'll see all the time. Since the game object is your root object, that's really what you want to destroy, and thereby destroying everything underneath it. So let's see what this looks like. We're going to run this guy. Move over to the side here, and that cube disappears.
You got that cube.
I got that cube. Got that cube. Oh yeah, I'm on a roll. I got 3 cubes. I'm cubed. Yes. So now what do we want to do next? Notice I've got a little text here, increment score.
Oh, there we go. Yeah, you always have to have scores in games.
So we can easily create an integer value called score. And next, we're going to want to create some reference to text on the screen. Let me delete what I have here so I can show you from scratch. This is Unity 4.6 beta right now, hopefully to be released shortly. You can get this beta on their website. This is everything I'm showing you today can be done with the free version. And I'm going to create, under the UI menu, text.
Ooh, this is that long-awaited UI that everyone's
UI initially called UGUI, now called UI, and so we'll see if that's the final name, but UI is what it looks like it's going to be. People waited a long time for this because the old system was kind of painful to use. Now you can drag and drop objects. It's so much nicer. So I'm going to create some text here. And you can see it creates this canvas element here. If I double click on it, there it is. Now let's take this text. I'm going to go into my 2x3 mode here because it makes this a little bit easier to see.
So you have to essentially drag that text within the bounds of that white square to make sure it's on the screen. Is that what I'm gathering?
And we can see it over there on the side. So this represents my screen. And this can actually see how it grows and sizes. That canvas dynamically changes to whatever size, essentially, device that you're on. So what I'm going to do here is I've got a couple fonts in my project, and you can just go over to, we were talking about earlier, something like thefont.com. Find a free font there.
Yeah.